Hello friends, welcome back to my channel. Up until now, we have done a lot of topics on how to find shortcut. We have done shortcuts for bond order. We have done shortcuts for hybridization. We have done shortcuts for determining the stability. Today, I'm going to club each and everything like hybridization, all the concepts of shape, structure, geometry, everything, and we will be doing lots of questions today, so that every concept that you have, every doubt you had, gets clarified, and you have very good confidence to deal with questions. So on this attempt, we'll start now with some problem solving. So shall we start? So get your pen and paper ready. You can play with me here. We'll do it together. So all of you, get set, go. Let's begin. So here is your first question. For each question, I'll be giving you 30 seconds time to do it. That is the threshold. Okay, try to stick to that limit, or maximum 1 minute. Don't go beyond that. Okay. So first one is a lollipop question. Very easy. Look at it. So let's go. This is the first question we have. This was asked in one of the CET exam. So let's begin. Pause the video, do it. The options are yes. Okay. So I hope you would have done it. Let's start. See, what's the answer to this question? The answer will be very easy. What is the answer? Bond order is nothing but, how many electrons does nitrogen have? N plus N, 14. The number of electron is 14. And if you remember, in one of the shortcut I've mentioned that if you get the total number of electron as 14, the bond order comes out to be excellent 3. And we also know that nitrogen has a triple bond between atoms. Excellent. So the answer is bond order 3. Option 1. See, it hardly takes 10 seconds to do it. So if you follow the techniques that I've shared, doing questions will be a minute's thing for you, and even lesser than that. You can do it very quickly. So the answer is option A. So let's begin. Let's go to the next part. Next question. Next question that they're asking is this one. See, they're asking what is the number of bonding, number of electron pairs, number of lone pairs in ClF3, SF4, BRF5. These are the options we have. Okay. Again, pause the video. Take a minute time. Please do it. Please pause the video. Okay. So I would have tried. Let's see how the solution works. ClF3. What is the shortcut I tell you for this question? The shortcut I told you was find the total valence electron. How many total valence electron this has? Chlorine 7. This fluorine 7 into 3. So 7 into 7. What is the answer? 7 times 4, 28. Divide 28 first by 8. Then we'll get the quotient is 3, 24, 4, 2. So 3 bond pairs and 2 lone pairs. If you don't know how to do it, you can visit my shortcut that I mentioned in the previous lecture. I'll give the link on the I button above. I'll give you the link for that shortcut video. You can go and watch and come back again and do these questions. So ClF3, 3 bond pairs, 2 lone pairs. They're asking bond pair and lone pair. So the answer is 3:2. So this is not the answer. This is not the answer. It could either be A and D. Elimination is very important. Now we just need to do one of these questions. Let's do for SF4. SF4. So what's the total valence electron? Yes, excellent. Sulfur has 6 electrons. Fluorine 7 into 4, 28. 28 plus 36 will be 34. Right? Now 30 divide 34 by 8 first. 8 4 32, 2. So 2 divided by 2. So 4 bond pairs, 1 lone pair. That's the way. So the answer is 4:1 or 4:1. So answer is option D. See, it takes hardly a minute to solve this question. So you're done with this as well. Let's go to the next question. So this is the correct answer. Next, which of the following does not have triple bond between the atoms? So how to do this question? I told you the shortcut, right? Remember? Find the total number of electrons. Okay, if the electron count is this, the bond order can be calculated like this. So bond electrons 14, bond order 3. Electrons 15, bond order 2.5. Excellent. 16, 2. Yeah, and then 13, 2.5. Keep decreasing by 0.5, 0.5. So 12, 2. So nitrogen has how many total electrons? 14 electrons. So what's the bond order? 3. That means it has triple bond, right? Bond order itself means number of bonds. Bond order means number of bonds, right? So Here, what's the number? 4, sorry, 6 because of carbon and 8 because of oxygen. Total number of electrons, so 14. Bond order is still 3. This also has triple bond. So this is not, these are not the answers. Next one, NO. 7 of nitrogen, 8 of oxygen. So our answer is 15 electrons. 15 means bond order is 2.5. So this is our answer. This is our answer. This is again 12 plus 2, 14 electrons. It will also be a triple bond one. So this cannot be the answer. So the answer is option number. Excellent. C is the right answer. I hope you're getting how to do this question. And see, we're just taking 10 seconds, 15 seconds. Next question they're asking is, which of the following have identical shape but different hybridization? Okay. So they're asking which of the following has identical shape but different hybridization. How to do it? Let's look at the options. Cool. So these are the options we have. So asking which of the following have different identical shape but different hybridization. How to do it? See, option A, let's explore. I3 minus. So please pause the video. You can try on your own, and then again you can restart the video and do it. Check what is the ideal way. So I3 minus, how many electrons does it have? Total valence electron will be 7 because of halogen, 3 times because there are 3 atoms, plus 1, that means 22. So 22 divided by 8. What's the answer? 8 2s are 16, 6, 2, 3. 2 bond pairs and 3 lone pairs, right? So it has 2 plus 3. What's the hybridization? Hybridization will be, it's 5, so it will be sp3d. Why? Because 1s, 1 3, 1d and 3. If you don't know how to do this, again go and see the video that I have uploaded, the last video I have uploaded, where I have explained this in very detail how to find this. So I3 minus is an hybridization of sp3d. Yeah. And what is the shape of this? So 2 plus 3, 5. That means it will have what kind of geometry? Yes, trigonal bipyramidal. So this is how it looks like. So I'll put one iodine in the middle because that's what they will go. One iodine here and one iodine here. And 2 lone pairs here. That's 3 lone pairs here. So how does it look like? See, it has linear shape. Linear shapes, right? Okay. Now look at the next option, BeCl2. So BeCl2, you can use the shortcut once again. Number of valence electron from beryllium is 2 because it belongs to group 2. Plus 7 into 2, 14. 14 plus 2, 16. 16. Divide 16 by 8 as usual, right? So 2. It will be 0. 2 bond pairs, 0 lone pairs. Just 2 bond pairs. How will it look like? Yes, excellent. Straight, linear. And what's the hybridization? Since we just have sum as 2, as per the shortcut I've given, it should be SP. SP. So this has, both of them are linear in shape, but different in hybridization. The answer is option A. You can try for others also, but since we got our answer and this is just one correct option, answer is definitely A. You can check for, like for example, I'll give you another ammonia one. Ammonia has a hybridization of sp3, okay, and the geometry is pyramidal. BF3 has geometry of trigonal planar, but hybridization is sp2. So this is not the answer. Similarly, you can try other options also, and that's how you can proceed with the question. So I hope it helps. Yeah, let's go to the next question. Question number 10. This was also asked in one of the CET exam. So let's see what the question is. Question has to say. Here they're asking, here they're asking the number of electrons in valence shell of a central atom of molecule is 8. Which molecule could it be? Okay. So asking which of the following has 8 electrons in the central atom. So let's look at the answer. Again, you can pause the video and try for 1 minute, as I told in the beginning of the lecture. Just spend a minute or 30 seconds. First do 30 seconds. If you don't, 1 minute, not more than that. If you don't know how to do it in less than a minute time, that means you're doing wrong. Learn the approach I have discussed in the previous lecture. Go through that and learn it. I can guarantee that will save a lot of time in your main exam. BH2. See, how many electrons does it have around it? Only 4. 2 electrons here and 2 electrons here. So 4 electrons. So this is not our answer. SCl2. How many? So see, chlorine has taken this, and so how many electrons does it have? Which of the following molecule has? Central atom molecule has 8 electrons. Number of electrons in valence shell of central atom of molecule is 8. So this is the one. See, how many electrons do we have? 2, 4, 6, 8, right? This is 2, 2, 2, 2. So how many do we have? Total of 8. So this is the one, this is what I was looking for. So if this has 8 electrons around it, so this is our answer. Why this is not the answer? Because here we have how many electrons around it? Absolutely correct, 12 electrons. So even this is not the answer, and neither is this, because BCl3 has a geometry like this. So the answer is option number 2. Let's go to the next question. Very good. If you got it correctly, this is how we do it. Next one. They're asking you to match the following. Okay. Yeah. So asking which of the following. Sorry about that, but we can now prove it. What is the right answer? So how to go for that? See, again, you can use my shortcut. Ammonia. Valence electron. Total valence electron will be 5 because of nitrogen. Very good. Plus 7 into 3. So how much do we get? 26. Divide 26 by 8. What do you get? 324. Then we have 2 divided by 2. We'll get 1. So 3 bond pairs, 1 lone pair. What is, how many lone pairs? How many pairs this central atom has? So 3 plus 1, 4. So it has 4. So ammonia has 4 pairs of, number of pairs is 4, right? Next, so total pair is 4. Water. I mean, we'll see what they're asking, but yeah, anyways, let's see. Let's find the other one. Let's see the water one. Water molecule. So again, if I find the shortcut, total valence electron will be 7 into 2 because of hydrogen is as octet, we told you, plus 6, so it will be 20. So 20 divided by 2, sorry, 8 first will give you 2, 16, 4, 2. So 2 bond pairs and 2 lone pairs. 2 bond pair, 2 lone pairs. So 2 plus 2, 4. When this has, the total has 4. XCF2. You can use the shortcut again. This has 4, this has 4. We'll see the options later on. XCF2. Then 8 because of xenon. 7 into 7, 14. So this is 22. 20 divided by 8 will give you 2, 16, 6, 2, 3. So 2 bond pairs, 3 lone pairs. The summation is 5. Very good. And the last one is methane. So methane has 4 bonds, no lone pairs. So 4 bond pairs, 0 lone pairs. So I think they're asking lone pairs. Otherwise, this option makes no sense. Yeah, the question makes no sense. So ammonia, methane has 0. That means D should be mapped with 3. So how many options are D3? Only one. That is the answer is option number 3. I can check the other ones also. Ammonia has how many lone pairs? 1. So A5. See, A5. Then B, water has how many lone pairs? 2. So B1. Even this is correct. 3. C is XCA2. How many lone pairs does it have? 3. Even this is correct. So the answer is option number 3. See, that's how we do it. So they are asking number of lone pairs. Good. Next question. Which of the following is the correct set? That means they're asking which of the following is the correctly mapped hybridization or shape. So let's do it. So we just did water thing. How to do it? Find the total valence electron. How much is that? 7 into 7, 14. 14 plus 6, 20. 20 divide 20 by 8, right? If we divide it by 8 first, what will happen? You will get, yes, excellent. We'll get divided by 2 to get 16. And then 6, 2. So water molecule has 20 divided by 16. Just a second. Water molecule has 7 into 7, 14. And hydrogen oxygen atom has a valence electron of 6. So they're asking which of the following is correct set, right? So what do we get here? 7 into 7, 14. And 14 plus 6, 20. Valence electron of oxygen is 6. We know that, right? So it will be 20. Divide 28 by 20. 20 by 8 first. We'll get 16. And then this is 4. So we'll get 2. So 2 bond pairs, 2 lone pairs. What's the hybridization? sp3. Even that is correct. And what's the shape? So water molecule has 2 lone pairs. So 2 lone pairs will go here and here, right? And hydrogen will come here. What is shape? What is shape? Please remember, shape is the structure without lone pair. Meaning, if I remove the lone pair, suppose I ignore the lone pair. Without lone pair, how does it look like? Suppose I ignore these two. It looks like an angular line. That means this is correct. BCl3. BCl3 looks like this. See? Therefore, it has only 3 sigma bonds. You can use the shortcut. The answer is sp2. So this is not the answer. Ammonium, it will be Not the answer. Tetrahedral. Actually, it is tetrahedral. You can use the shortcut that I've discussed to find it. And this is not the answer as well, because methane is simple tetrahedral molecule. It will not be DsP2. It will be sp3d. sp3. It will also be sp3. So the answer is option A. Let's see what they have to say. Yes, very good. The A is the right answer. Next question. Which of the following is not tetrahedral? You can use again do it by using the shortcut that I've taught you. Yeah. So which of the following is not tetrahedral? So the following common molecules are not tetrahedral are, just use the shortcut. Total valence electron. Boron has a valence electron of 3 because it belongs to group 13. Fluorine 7. 4 times plus 1. What do you get? You get 4, 32. 30 divided by 8 will give you 4, 32, 0. So 4 meaning sp3, sp3 meaning tetrahedral. So this is, they're asking which is not tetrahedral. So this is not the answer definitely. How about ammonium? Ammonium, again you can do this same shortcut. 5 into 7 into 4 minus 1, which is 32 again, divided by 8. 4, 32, 0. So it will be sp3 again. So it's just tetrahedral once again. 4 means tetrahedral. Even this is not the answer. Carbonate. Use the shortcut. 4 because of carbon. 6 into 3 plus 2. So what is the answer? Yes, 24. 24 divided by 8 will be 3. 24, 0. So 3 bond pairs, no lone pair, nothing. It will be sp2. And since it's sp2, it will be trigonal bipyramidal. So this is the right answer. Even this will be tetrahedral, you can check. So the answer is option number C. Very good. That's the correct answer. This is how we do it. Okay, I'm moving to the next question now. Please note it down if you want to. Next question. Hybridization of oxygen and diethyl ether will be what? What is diethyl ether? ROR is called as diethyl ether. You can say instead of R we have C2H5. But that's not, so important. The important thing is there are 2 lone pairs here on oxygen to complete the octet. See, 2 bond pairs and 2 lone pairs. What will it give you? 4. 4 meaning sp3 hybridization. So answer is C. See, we can do it literally in seconds, guys. It doesn't take much time, Moving on. Next question. Which of the following is a linear molecule? So we are doing ample of questions. I hope you're enjoying it. And now this is the time you do it faster than me. Let's see. Let's see who can do it faster than me. So first, VCl2. So I'm getting old. You guys are young. You can do it quickly. So total valence electron will be 2 plus 7 plus 1, 14. So this will be 16. 8. See, I can do mistakes also like this. In between. 2 means sp hybridization. Since it is sp hybridization, it will be linear, right? See, it will be linear. So this is the answer. But you can check the other molecules also. Water, definitely not linear, right? Because of the lone pair repulsion, it will become bent. SO2, because of the lone pair, it will become angular or bent. Methane has tetrahedral structure like this, So even if this is not linear, the answer is option number A. I hope you guys have done it faster than me. Next question, definitely I want you to do. Before I tell you the answer, you should tell me the answer. Okay. So please go ahead. They're asking which of the following is the correct set of molecule. This was asked in one of the engineering entrance exam in 2003, as you can see. So let's do it. Yes. So what's the answer? Please pause the video and do it quick. So we have been given VCl2. Yeah, let's do it now. Total valence electron will be 2 plus 7 into 4, 7 into 14, 16. Divide 16 by 2. What's the hybridization? Value comes out to be 2. 2 meaning 1s and 1p. And it will be linear. So BCl2 is P. This is not the answer. Not the answer. BCl3. Use the shortcut once again. Total valence electron. For those who don't know how to do this one, you can go to, as I told you, go through the lecture. I have linked it, on the I button above. I have given you the link for that video. You can go and watch, and again come back and do it. So 3 plus 7 to 3, 21, 24. 24 divided by 8, 3, 24, 0. 3 means sp2. sp2 meaning 1 plus 2, 3. 3 meaning tri. So trigonal planar. See, that's how things are related to each other. I got 3, then I am saying that 3, try. If I would have got 4, I would have said tetra. If I would have got 5, I would have said try by. So the answer is option number C, not D, definitely. Yes, see, we are correct again. This is how we do it. Write it down quick. Okay, now I'm going to the next part. Next question, which of the following is correct set? So why don't I leave this question for you? Please do it. Let's take it as a quiz. So please, your time starts now. Do it. Okay, so can we discuss the answer? Yes, of course, it has to be water. Why? Because water molecule has 2 lone pairs, right? You can find that using shortcut. It won't be linear. It's a bent line, like this. 2 lone pairs on. We don't consider lone pair, right? So this is not the answer. Could it be this? No. Hybridization is sp3. Could it be this? Hybridization. We just did this question. Excellent, guys. Next question. Which of the following is correct with respect to its formula, hybridization, and shape? So CO2. What's its structure? See, this is the structure. How many sigma bond does it have? 2. So hybridization will be sp, and shape will be linear. So this is not the answer. Next question. Water. Water has 2 lone pairs. See, 2 lone pairs. So because of this, the structure is bent, and hybridization will be sp3 because 2 bond pairs and 2 lone pairs, sp3. This is not the answer, right? Next question. BCl2 linear. Could it be the answer? Could this be the answer? Let's check. So BCl2 has a linear structure. You can check using shortcut also. Beryllium is 2, chlorine is 14. So 16 divided by 8 first. 2, 16, 0. So 2 means sp. Hybridization is sp, and the structure is linear. So the answer is option C, not even D, because D will not be linear. Okay, that's the right answer. So now they're asking what is the hybridization of ammonium ion. We have done this already so many times. How to do it? Please try with me. Pause the video, do it. The moment you saw the question, pause it, do it, again watch back when you're done. Yeah. Let this be the practice. Now, nitrogen 5, hydrogen 28, minus 1 because it just lost an electron. 32, divide 32 by 8. What do we get? 4. 4 meaning 0. 4 means sp3. See? sp3. Simple. It takes 30 seconds, guys. Not even that. See, it's very easy. Cool. Next question. Oops. Anyways, we can prove that point. Which of the following has, they're asking ammonia and CH4 has CH4 has sp2 hybridization? Not really. You can check. Ammonia has the valence electron of 5 plus 7 into 6, 21, 26. 26 meaning 8, 3, 24, 2, 2, 1. 3 bond pairs, 1 lone pair. So 3 plus 1 is 4. Hybridization is sp3, not sp2. This is wrong. BCl2 has B shape and SO2 is linear? Not really. BCl2 is linear and SO2 is V shape. This is also wrong. SF4 is octahedral. Let's check. See, CO2 has no dipole moment. Why? Because the oxygen is more electronegative, so dipole goes this way. Dipole go this way, so they cancel each other. So mu is 0. Even this is wrong. The correct answer is C. And you can check also SF6 has a geometry which looks like this, where all the bond angles are 90 degree, which we know, right? This is 90, this is 90, this is 90, this is 90, this is 90. Everyone's 90. It's like a square on the plane, and this is up and this is down. Up, down. Even those are 90, 90. So the answer is option C. Excellent. C. This is something that I'll just put this there, and they can practice more and more question for you. Please practice and check this is the right answer. Next one. Now we have some JEE question that we'll do. So let's start. This was asked in JEE Mains 2015. So please do it. Those were the CET questions, and now we are doing JEE questions. So please join in. Pause the video, do it. Okay, let's discuss it now. The XeO4. How to do it? Same shortcut. Total valence electron, xenon will be 8. Oxygen 6. Fluorine 7 into 4. So what do we get? We get it as 8 plus 6, 14 plus 28. What's the value? It will be 42. Now, divide 42 by 8 first. What do you get? 5, 40, 2, 2, 1. So 5 bond pairs and 1 lone pair. What is 5 plus 1? Yes, 6. 6 meaning octahedral. Octahedral. See, it's there in the chat that I mentioned. Yeah, so answer should be octahedral, option A. See, but they're asking geometry. Okay. Okay, they're asking geometry, right? This is not, this is the shape actually. This is the structure, my bad. Yeah, they're asking geometry, right? How to do geometry? This is the shape, by the way. Okay. What is geometry? If you remember, I have told you geometry is nothing but it's shape without lone pairs, right? Without lone pairs. So tell me, how will it look like? XC 1, 2, 3, 4, 5, 6. This is how we draw it, right? So there are 5. One double bond oxygens will go on top as usual, right? One lone pair at the bottom, fluorine, 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 fluorine. So tell me, how does it look like? It looks like there's a square on which there's a pyramid kept. See this pyramid. See, hence the name is square pyramidal. That is the geometry of this question. Yeah. So the answer is option A. A is basically the structure. C is the right answer because she's the that is the geometry of the molecule. I hope you got it. See, that's how it looks like. Look at pyramid. See, pyramid. Okay. Next question. Cool. This was asked in 2014 JEE Mains. Which of the following is unpaired electron? If you go to my last shortcut, I mentioned that if you have a paramagnetic substance, okay, that means you should have odd number of electrons or 10 or 16. Then this is paramagnetic, and the moment it is paramagnetic, it will definitely contain unpaired electrons. Definitely, because that is the main condition for something to be paramagnetic. So N2 has how many electrons? 14. Is it 10? No. Is it 16? No. Is it odd? No. That's diamagnetic. So is this the answer? No. O2 minus. How many electrons are there? 16 plus 1, 17 electrons. Is it odd number? Yes, it is paramagnetic. This is the answer. Although we can check the other options. See, look at N2 2 minus, N2 2 plus. How many electrons N2 has? 14. How many are we removing? 2. So how many electrons it has now? 12. Is it an even number and not 10, 16? Yes, this is diamagnetic. So not our answer. O2 2 minus, peroxide, right? What will be the answer? 16 plus 2, 18. Is it an even number? Is it 10, 16? No. Therefore, it will be diamagnetic. So the answer is option number B. Excellent. This is how we do it. This is a concept I mentioned in the last video. Again, link is on the top. Paramagnetic contains odd number of electrons or 10 or 16. Then they are paramagnetic. And as they are paramagnetic, they must contain unpaired electrons. Simple. Okay. Moving on to the next question. They're asking, which of the following is the correct order of arrangement of their energy? Okay, that means bond dissociation energy. They're asking which one will have more bond energy. So bond order is proportional to bond energy. That's what we know as a theory. Again, I have discussed in the previous lectures. So if the bond number of electron is 14, bond order is 3. Number of electron 13, bond order is 2.5. Number of electron is 12, bond is 2. You know this thing, right? 2.5, sorry. Keep decreasing it. 15, 2.5, 16, 2. 13 will 12 will be 2 and so on. Keep decreasing, keep increasing it. Now let's see what are the species we have. We have N2, O2 minus and O2. N2 has how many electrons? 14. Bond order 3. O2 minus has how many electrons, guys? Please tell me. 17. What's the bond order? 2, 1.5. That's pretty low, right? Yeah. O2 will be 2. So what's the answer? N2 more than O2, O2 more than O2 minus. N2 more than, see, more the bond order, more the bond energy. Simple. So N2 more than O2, O2 more than O2 minus. Which option? Option number C. See, that's how we can do it. JEE 2014 question solved within a minute time. Okay, very well. Let's go to the next question. Which of the following is paramagnetic? How to do this question? This is kind of tricky, right? Is it really difficult? No. Just add the electron. If it comes out to be even, paramagnetic except 10 and 16. Sorry, if it is comes out to be even, then it will be diamagnetic except 10 and 16. So nitrogen, 14 electrons. Para, no, dia. Is it paramagnetic? Not really. NO, 8 plus 7. How many electrons? 15. Is it even? No. Is it odd? Yes. Since it is odd, paramagnetic. CO, 8 plus 6. What's the answer? 14. Is it odd? No. It's even. Is it 10, 16? No. So it is diamagnetic. O3 is definitely diamagnetic because it will have this geometry, no free electrons. See, no unpaired electrons. So the answer is option number B. Okay, next. This is a very, very good question. They asked in 2015 JEE Mains. So what are they asking? In which of the following ionization process the bond energy has increase and also magnetic behavior has changed from para to dia? So they're asking which of the following has increased its bond order as well as magnetic behavior from para to dia. Hmm? So first question, 12, carbon plus carbon, 6 plus 6. So pause the video first. I'll not tell you now. Sorry. I should give it time also. Yeah. So guys, please pause the video and do it. Okay, welcome back. Let's continue. So C2, how many electrons? 12 electrons. How many electrons here? 11 electrons. 12 meaning bond order will be 14 is 3, 13 is 2.5, 15 is 2.5, 16 is 2, 12 is 2. That's how we do it, yeah. 11 is 1.5. So this is 1.5. Yes, and this is what? This is 2. So 2 to 1.5. The magnetic, this is not increasing. This is not the answer. B option. 8 because of oxygen, 7 because of nitrogen. So 15 electrons. This is 14 electrons. So 15 to 14. What do we have? Paramagnetic to diamagnetic. See, it's moving from para to dia. Right? I think this could be our answer. Let's see. What's the bond order? So because of the 14 electron, the bond order is 2.5. See, 15 electron is 2.5. And because of 14 electron, it will be 3. So bond order increases. Magnetic behavior decreases. The answer is option number. Very well. B is the right answer. See, you can do it in seconds. You can try for others option also, they will not match. Okay, next question. Which of the following is the correct option regarding these species? So let me write them once again. We have O2 plus, then we have oxygen, then we have superoxide, and then we have peroxide. So for those who don't know the names, let me tell you the names quickly. See, this one is called as peroxide. This one is called as superoxide. This one is called as oxygen, and that we know it's oxygen ion. Now, see how to do this question. They're asking OO distance. So bond order is proportional to 1 by bond length. I have mentioned this in the last lecture, right? So if bond order is more, bond length is shorter, and the vice versa. So O2 plus is how many electrons? See, it will have 15 electrons. How many electrons? 16 electrons. How many electrons? 17 electrons. How many electrons? 18 electrons. So 18 electron meaning bond order will be 1. That's the bond order. We discussed it. 17 meaning the bond order will be 1.5. Because that's how they look like. See, peroxide looks like this. So bond order is 1. This is peroxide. 16 meaning 2. 15 meaning 2.5. So the answer is O2 is the shortest because it has the highest bond order. Then we have O2 and then we have O2 minus and then we have O2 minus. So this is the bond order. So what is the bond length order? Opposite. So the last one is peroxide, as you can see in the question. See, last one is peroxide. So last one should be the largest value. Where do we have that? Only one option has that. Option D. So that is our right answer. See, that's how we can do it. This is how we can explain it. So please write it down. Okay. So I hope you're getting these questions now. This is how we can approach it. Okay, this is something that we did in the last class. This was asked in the 2013 exam. So I told you, right? It's always the neutral molecule, then the cation because it has electrons in anti-bonding electron. See, yes, electron is in bonding orbital, bonding molecular orbital. This guy has electrons in anti-bonding molecular orbital. So because of these reasons, this has more stability than this. You can refer the old lecture. I've done the exact same question in class. So the answer is option number A. See, Li2 is the higher, most stable one, and then we have Li2 plus, then we have Li2 minus. That's how we can do it. Because electron, if the electron is present in ABMO, that's not a good case. It makes it unstable. Okay. So now we are at the last question for this lecture. After this, I'll be giving this presentation to you so that you can practice more and more. There are some more questions in this presentation, and I'll add another worksheet from which you can do more and more questions of this type. Okay, so for now, let's do this question. So please pause the video, do it. Okay, I hope you're back now. So see, 14 electrons, add it, 7 plus 7, 8 plus 8, 16 electrons, S2 plus S2, just like oxygen, yeah, carbon will be 14 electrons. So this is 14, this is 16, this is just like oxygen, because you see, oxygen and sulfur belongs to same family. So they both are paramagnetic. Why? Because of the same reason, as they have 16 electrons in the last shell, as I told you, and sulfur looks exactly like oxygen because of same number of valence electron. So these two are para, so not our answer. Even this is, which of the following is expected to be paramagnetic? C2 is 12, right? Which of the following could be diamagnetic? Definitely option A. Option A is the right answer. That's how we can do it. Even D could be correct, as I told you, because it has 12 electrons, right? So even this could be correct. But if you have to choose one, then you can choose A. But if you want, see, both of them are correct, right? Because here it is an even number. Even number means diamagnetic, unless it is 10 or 16. So we have done ample amount of questions on hybridization, shape, bond order, bond length, stability, and all these things. So I hope you enjoyed this session and you learned a lot more new things today. I'm going to upload this in the description below this presentation so that you can do more questions of this type. And you can redo this question if you want to. So I hope this was a helpful session, friends. So if you're liking this series, please share it to your friends and please subscribe to my channel for such amazing content in the future. So thank you so much, guys.